Hello everyone, welcome to my YouTube channel. Today we will be solving Leetcode 994 rotting oranges. So it is a very famous question of a graph traversal. So the question states that we have given M cross N grid where each cell have one of three values. If the value is 0 means it represent an empty cell. The value 1 represent the fresh oranges and value 2 represent the rotten oranges. We have also given that every minute, any fresh oranges that is four directionally adjacent to a rotten oranges become rotten. Return the minimum number of minutes that must be elapsed until no cell has a fresh orange. If this is impossible, means it is impossible to make all the oranges rotten, then we have to return -1. Like we have given this example. Like we have given this example, let's understand what it is saying. So we have given this oranges rotten. So in first minute, it will four directionally infect the fresh oranges. So this infect this orange and this orange in first minute. So in first minute, this is already rotten, and but this orange and this orange become the rotten. Now in the next minute, these three oranges will rotten the fresh oranges. So this is already checked for its neighbors and make them rotten, then its neighbor will check for the next. So for this node, this make this orange rotten and this orange rotten, and it does not have any access to the other. For this is already rotten and its all neighbors are rotten. Here are the empty cells, so there will be no rotten oranges. So it will make these five oranges rotten. In the minute 2, next minute, these new rotten oranges infect their adjacent oranges. Like in next minute, this is only accessible fresh orange. So in next minute, it will be rotten. Then after that, next minute, this make the fresh oranges rotten. So in 4 minutes, means in step 1, two oranges became rotten. Step 2, these two means minute 2, these two, and minute 3, this, and minute 4, this. Then we will check that all is rotten. If all is rotten, then we will return 4. So this is our problem. How we will solve this problem? We will solve this problem by the BFS approach. BFS. In this problem, we will create a queue. Like if we make our this is our so 3 0. So which have value 2. This is rotten, and this, 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 and this is fresh oranges. So what we will do? What we will do? We will create a queue. We will create a queue, and we will store the indices. First, we will check in the array whose value is 2. We will check. We will check in the array whose values is 2. We will store in the queue. So like for this, if we mark in index 1 2 0 1 2 0 1, so 0 0 indices are marked rotten. Then we will four directionally check if it has any fresh oranges. Initially, we set our time equal to 0. We will check four directional. It has a fresh rotten oranges. So this is processed, but next oranges is inserted. Then our 0 comma 1 is inserted, and if it is inserted we will make it rotten. After that it has another 1 comma 0, it has another 1 comma 0, so we will insert that into the queue and we will make it rotten. For every insertion we will update the time by 1, so it is in first minute. So in second minute we have first value of 0 1, we will pop this value and we will find its next adjacent neighbor. We will try to find its next adjacent neighbor. So it has adjacent neighbor of this and this, but this is previously rotten, so we will not include it. It has a first, like on the index 0 comma 2, and it will make it rotten, and it has for us 1 comma 1, so it will make also it rotten. Now for every iteration we initially value 2, but in first minute these two values are marked, so this value is popped, then we will check for this value. This value does not have any fresh oranges, then this value mark. Now in these two values, then now for third minute we will pop 02. 02 does not have any fresh oranges connected, so we will remove from this and go to the 11. 11 has a fresh oranges 2 comma 1, then we will make it rotten and increase the time by 1. Then for 2 comma 1 we have 1 fresh oranges, then we will add it into our queue, then it will mark to rotten. So this is process. After this is process, it does not have any fresh oranges, so we will make it rotten. So what we will do for this value means for every item, first we will insert initially rotten oranges into our queue, then we will remove from the queue, means remove from queue. How many values remove? We will remove size, means what was the size, we will remove those values from the every iteration. So like here the value will be 4 for the last one, like in the first phase there are only one value 0. If the value is 0, then we will remove 0 and insert next two values, but in the second phase we will remove this value, means 0 comma 0, this is the first phase. In second phase we will remove 0 comma 1 and 1 comma 0. In third iteration we will remove 0 comma 2 and 1 comma 1. In fourth iteration we will make 2 comma 1 rotten. In fifth iteration we will make 2 comma 2 rotten. So it take 1 second, then 2 second, then 3 second, then 4 second. So what we will do, every time we have any fresh oranges adjacent co-directionally adjacent to these nodes, then we will change their value to 2 and add them into the queue. This is our simple process how we will solve this problem. So let's understand the code. So we have given rotten oranges and we have given a grid. We find the number of rows and number of column, and the one main thing we have done that we check that our all the fresh oranges are rotten or not, means initially we will count how many fresh oranges we have. Like if we go to this example, how many fresh oranges initially we have 1 2 3 4 5 6, we have 6 fresh oranges, but as soon as we make them infect we will reduce the value by 1. So if Disinfected 1, disinfected 2, disinfected 3, disinfected 4, disinfected 5, disinfected 6. So all the values will infect. So we have fresh fruit 0. So in this code we check that we create a variable fresh and we create a queue for our BFS. Then we check into the grid. If grid of ij value 2 means it is rotten, then we will add this value into our queue. Else if means if this is fresh oranges, then we will increase the count of fresh oranges by 1. Means in this way we add the all first rotten oranges that was initially rotten into our queue and find the number of fresh oranges into the grid. Then we create a two-dimensional direction grid. For up means I minus I means up, bottom, left, right, and our minute is 0. So we will do this process until our queue is not empty and fresh is greater than 0. So we will find the size of the queue for the particular iteration and we will iterate I equal to 0 to the size means queue size. It is the basic structure of the BFS in the graph. So then find the current value means we will find the current value from the queue first element. Then for every direction means we have to make call for every direction. So for every direction we will add the current indices plus the direction we have to make. So in this way we find our new row and column. Then we have to check for the boundary condition means if x is greater than or equal to 0 and x is less than means it does not exceeded the boundary and grid of xy is equal to 1 means it is fresh oranges. Then for every adjacent we will make xy means we will make the fresh orange to the rotten orange and add them into the queue and decrease the fresh count by 1. So this process will four directionally check the fresh oranges and make them rotten and add them into the queue. Then after this for loop is done means for every we will remove every size element from the queue because they both infect in the same time like this and this will infect in the same minute to the each adjacent. So after that we will increase our minute value by 1. Then in last we will check that if our all fresh oranges are done means we have processed we have make rotten all the fresh oranges. If it is 0 initially we count the number of fresh oranges and as soon as we are inserting we are making the fresh oranges rotten we are decreasing the value by 1. So if our fresh value is equal to 0 then we will return the number of minutes we taken to make all the oranges rotten. Otherwise we will return -1 means it is impossible to make all the oranges rotten. Like in this example if you see if we remove this gap then these oranges will not be rotten. So in this case we will return -1 if we submit it. So with 72.5% user, very good solution. So in BFS call what we are doing, we are creating a queue and we are iterating into the grid. So if we observe with time complexity, so it takes m cross n and take m cross n. That's it. It is only taking m cross n. This will take n cross m. This will take like for the size n plus 4, like n plus 4. So overall complexity will be n cross m. For space complexity, we are creating a queue which will search all the elements. So we are creating n plus m, n cross m. This is our space complexity. That's all.